Welcome to ERC Tipsnology. In this video, we will be learning how to create a series parallel circuit using the Multisim Live or multisim.com. First, of course, you have to create your own account in multisim.com, and after that, open a new circuit or create a new circuit. And from here, we can now create our series parallel circuit. So let's start. First, let's click on the resistor here on the left side and put it on our screen. We can make the screen wider or bigger by clicking the plus symbol at the top. And then let's create another resistor here and drag it in the middle of the screen and click resistor symbol and put another one here, R3. Then let's make the R2 to rotate clockwise and also with R3. Then let's align them so that it will look better. So we put the R3 and the R2 on the same or aligned to each other as a parallel or two resistors in parallel. And R1 will be connected in series with our voltage source. So let's put a voltage source over here. Click the voltage source symbol and then connect this voltage source to R1. Now let's cancel the net label of our wire. So let's click on net labels and it's gone. And let's change the name of our voltage V1 into VS to represent voltage source. And let's put this as 25 volts, 25, and then let's connect R1 to R2, same with the label. Let's cancel the label. Let's connect R3 to our R1 intersection with R2, and then the negative side of the voltage source, let's put it to R2 and cancel the net label, and then let's click on the R3 and connect that to the bottom of R2 and cancel the net label is cancelled already, so we have to put the ground. So let's put the ground over here. Okay, that's it. And then let's change some values of the values of the resistors. Let's make this 100 ohms. Let's make this 500 ohms, and let's keep it as 1 kilo ohm on the right side. Okay, now let's measure let's first measure the voltages. So click voltage or voltmeter here, and let's put it on at the top of the VS, and let's call it as VS or for the name of the probe. And then let's get another voltmeter and put it on the left side of the R1, but we need to put a reference. So voltage reference on the right, on the left is our probe number 1, which we will change into V1. And the negative or the reference, voltage reference will not be the ground, but instead we will click on ref1 or reference 1. Let's select another voltmeter and put it at the top of R2, at the top of R2, and let's put another reference, voltage reference here at the bottom. Or we may opt not to put the voltage reference because it's the same as the ground, so we can cancel this reference. And so let's put another voltmeter here at the top of R3, and so the reference will also be the ground. So let's check on the name PR1. Let's change it to V2, and PR2 would become V3. So let's cancel that one and let's make it V3. Okay, now let's try to run the circuit. Click it and you will see here that we have 25 volts connected to our VS, correct? but the V1 is not 25. It's equal to 5.7692 volts. But from V2, it's equal to 19.231, and the same with V3, which is also 19.231. And this can be explained with the fact that the R2 and R3 are connected in parallel. So in parallel circuits, the voltages would be the same. And so when you add 5.7692 plus 19.231, the answer will become 25 volts. So there you go. This is how to create the series parallel circuit and how to measure the voltages. But we are not yet done. We have to measure the current. Now we will stop the running of the circuit or executing the circuit, and let's create an ammeter over here that would represent our I total, and the I total will have to be measured to know what will be its value. And expectedly we will see that the I total and the I1 will be the same. So let's get another ammeter here, and let's connect it here after the R1. And when you run the system or the program or the circuit, you will see here that we got 57.692 milliamperes here. And at the top or on the right side of R1, we got the same current of 57.692 milliamperes. So it proves that the R1 is really in series with VS because they have the same current. Now let's try to stop the circuit and put another ammeter after the or before the R2, or although we may also put the ammeter after R2. And let's put the name here as I2, and let's put another ammeter before the R3 like this. Click it up before the R3, and let's change its name into I3. And there you go. You have your 3 ammeters to measure the I total, or 4 ammeters to measure the I total, the I1, the I2, and the I3. Let's run the circuit and let's see how it will come. So the current on I2 is 38.462 milliamperes, and in I3 it's 19.231. If we add these two, it would give us 57.692 milliamperes. So that proves the Kirchhoff's current law, that the current going into a node is equal to the sum of the resistors or the currents along the resistors coming out from the same node. So the total current coming in equals the total current coming out. That's the rule for Kirchhoff's current law. Now let's stop the running of the program or the system, and that's it. We have measured the voltages and the currents of a series parallel circuit. So I hope you like our video for today and you learned something about series parallel, and please subscribe and have a nice day.